Hey everybody, it's Lon.TV. For the last 8 or 9 years, I've been using a WD MyCloud PR2100 NAS device as my home media server. This thing runs my Plex server. It also runs my HD home run DVR software. It basically is my hub for media. And although it's been working fine, it is getting a bit older. It's on gigabit Ethernet, for example, even though I have a multi-gig network now. Its processor can't handle a lot of the newer video formats for hardware-based transcoding in Plex. And sometimes it's just fun to try something new and different that might give you a little bit more flexibility, especially installing Docker containers and other self-hosted applications. So what I've settled on, at least for now, is this crazy setup here. And it involves this new device from GMKTec called the G9. Now this is an N150 Intel mini PC, but they're billing this as a network attached storage device because inside of it you've got 4 NVMe slots, so you can have a solid state array. And in addition to that fast storage, it also has a fast USB-C port. This is a USB-C 3.2 port that can operate at 10 gigabits per second. And with this port, I can connect up a drive array like this one that came in through the Amazon Vine program. This is called the Wavlink, and it allows me to install 4 hard drives in this array and connect it up to the device here for storing a lot of my large media files. And together, this thing has actually been running really nicely over the past week as I've been getting it set up and experimenting with it. So I thought I would share with you how this hacked together thing is working so far. And for a network operating system, I chose Unraid, which we've covered in the past. In fact, I will put links down in the video description to cover all the things that I've already talked about as I've been learning about Unraid and getting some of this self-hosted stuff figured out. So in this video, we'll take a look and see how well this device performs and how well it works when you've got additional storage attached for media. NVMe storage has come down in price considerably, but those 4 terabyte drives are still quite pricey. And so it's probably not all that practical from a cost standpoint to load this thing up with a bunch of high-capacity NVMe storage, which is why I connected up this thing. One caution I want to make here is that right now, Unraid does not support the N150 processor's GPU. That support is coming with Unraid 7.1, which will be shipping in about a month from when I'm recording this video. So we'll talk about Plex here, especially how I use it. But if you're doing a lot of transcoding, this is not going to be the solution for you just yet with Unraid. But if you were running this with the latest version of Ubuntu or Windows, this will be just fine. We did run some N150 transcoding tests on N150 hardware just the other day here on the channel. So just keep that in mind as we work our way through the review. Now, I do want to let you know, in the interest of full disclosure, that the Wavlink enclosure here came in free of charge through the Amazon Vine program, and the GMKTec PC came in free of charge from GMKTec. However, none of these companies has reviewed or approved what you're about to see before it was uploaded. No other compensation was received, and all opinions are my own. So let's get into it now and see how my crazy NAS setup here is working. Now, the price point on the mini PC here is about $239 with a 512 gigabyte SSD already installed on it. They do sell a diskless version direct on their website that might cost a little less, and I'll put affiliate links for everything down below in the video description. This Wavlink drive array without any disks costs about $115, so not very expensive. And if you got some storage laying around, you can just load it up and you are good to go. Now let's start off though with the mini PC for a hardware overview here. This is powered by an Intel N150 processor. It's basically the same guts as their very low-cost mini PC we've looked at now a bunch of times here on the channel, and it performs pretty much the same. But this one, of course, has all of that extra storage capacity. So here you can install, like I have, 4 NVMe SSDs. I think it's this slot here that will also take an SATA drive if you have one of those laying around. But one thing I noticed is that there is no active cooling in this NVMe chamber. I did later install some heat sinks, which did help a little bit, but things are still getting a little bit too warm for my comfort level, and I think you'll probably want to avoid some of the more higher power consuming drives as a result. Now, although the storage is very upgradable on this, the RAM is not. These have 12 gigabytes of RAM soldered on the motherboard that cannot be upgraded, at least not upgraded easily. So that's the one limiting factor here. I think if you're running a lot of self-hosted applications, this is probably not going to be a good fit for you because the RAM just can't be upgraded. However, in my use case, 12 gigs is fine. I'm only using about a gig with the operating system and the Plex server running, along with a few other little Docker things I've been messing around with. So far, RAM has not been a limitation for me, but it might be for you. 12 gigs is all you get. And then on the back here, you can see all the ports that you get, which you don't get on their lower cost device. So the one that's most important to me is this one right here. This is a 10 gigabit per second USB-C 3.2 port. And this is what will allow us to get this drive array working pretty much at its full speed, even though it's externally attached. You have two HDMI outputs here. You can actually get additional video output from the USB Type-C port for a total of 3 displays. This actually comes with Windows 11 Pro pre-installed, so you could use this like a regular PC, just with a lot of storage on it if you choose to go that route. I did not keep Windows on this one, as you'll see, but it is an option if you want to go that route, and of course it runs Linux just fine too. You have two 2.5 gigabit Ethernet jacks here in the back. These are Intel-based Ethernet controllers as well, so no problems with compatibility there. Headphone microphone jack here. This is where the power goes. This port doesn't support power, unfortunately. And then on the side here, you've got 3 more 5 gigabit per second USB-A ports. So a nice little device here, especially for running it as a media server, which we intend to do. So that is the mini PC component. Let's take a look at the drive array real quick here. This is not one of the best built devices I have tested in this space, but for the price point, I'm not complaining. What I don't like about it is that it's got this whole pull-out thing for the entire mechanism, and the drives have to be screwed into each of these trays. So you've got 2 trays here that each support 2 drives. So it's not something like a Synology NAS where you can just pull it out and replace it with a hot swap. It's going to require a little more work to get a drive out and replaced. You could potentially do it while it's running, but I would not recommend it just given how brittle it feels based on this plastic cage and everything. It's just not very well constructed. So I would advise, if you do intend on replacing drives often, probably not getting this one, but for my purposes, where I'm going to be very rarely swapping out drives, this is just fine for, at least for now. On the back here, you can see some other oddities. Each drive has its own power switch, so theoretically you could power down the bad drive and swap it out or whatever, but it's not a hot swappable type of array, I don't think. You also have a master power switch here to get everything up and running. Now you will notice that there's an HDMI output on this. This itself doesn't output HDMI, but if you're connecting it to the USB-C port that I've got on our mini PC that supports video output, you will be able to plug a monitor into this and get display output. Additionally, it has enough power to power the array and also provides 60 watts to the device that you're plugging it into. So if you have a full service USB-C port, this array can be your video output and your power going in, because it's effectively a little docking station. It just doesn't have all the ports that a docking station typically has. You also get another Type-C port here. Theoretically, you could daisy chain these things together if you have a couple of them. The problem, though, is that you're all working off of a single USB-C 10 gigabit bus, which will very quickly get saturated with all those drives attached. But you do have that as a potential option here. So just for the price point, I think it works quite well. It's keeping my drives cool, and it's been functioning better than I expected it would, especially given that it's been running now for a week without any issues whatsoever. Now, I am running a bunch of NAS drives in here right now. I think I've got some Toshibas. This did work with a bunch of SATA SSDs that I installed into it earlier. However, one of the SSDs wouldn't power up unless I cycled its little switch there in the back. So I think spinning drives are probably the better way to go on this thing. And from a throughput perspective, as you'll see in a minute, I'm able to get about 200 megabytes per second, if not a little bit more, out of individual drives here, which is what I would expect. Now, when I did have all of the SSDs installed earlier, I did set up a RAID 0 striped array on my Mac, and I was getting about 450 megabytes per second for its max throughput. So not terribly fast here, but for Unraid and for media serving, it is working just fine for me. One important note, though, is that it doesn't look like you can get software RAID to work with Windows on this. It just would not build the array when I tried to do it through the disk management thing, either with the solid state drives or with these drives that I have in it now. So be aware of that. That's a big limitation of this. But because Unraid is Unraid, it addresses each drive individually, that's not a problem for this project. But if you were intending on running some software RAID on this, it doesn't appear like that's the intended use case, and they even speak against doing it in the product marketing. All right, so I've got Unraid all up and running now. And you don't need a display for Unraid. It runs headless. You have everything done through a web interface here, as you can see. Now, as you can also see, if you look down at the processor section, we're pretty much at idle here. A couple little things hitting here or there, but generally running without much going on. And to my surprise, the mini PC is drawing about 26 watts just sitting here. And I suspect that a lot of that power consumption comes from the 4 NVMe drives we have installed on the bottom of the system. So whatever drives you install will probably drive some of that power consumption. But that's quite a bit for this array. And this does not include, of course, what this device is currently drawing with all the drives installed on it as well. Why don't we take a look at what I've got set up here. I'll go over to my main menu here. And what I did is I took four 4-terabyte drives and put them in this array. And I have one of them as the Unraid parity drive. And if you watch my Unraid video, you'll know that you have to have a drive that's at least the same size as your larger disk or larger in order to give you some data protection. But of course, good backups are also recommended. So I've got a total of 12 terabytes for my media array here. And then I've got the solid state drives here also. I've got two 1-terabyte drives, some Sabrent, and the one that it came with, which was another 1-terabyte drive. And then I set up a cache drive here, which I might use with the media array later. That's a 500 gig WD drive. So you can see how everything is arrayed there. If we go over to my shares, I've got to figure out why I'm getting this unprotected warning here. But if we look at my media drive here, as you can see, I have it only writing to disks 1, 2, and 3, which are the mechanical drives inside of the array here. So I'm not going to copy any movies onto those NVMe drives. It's all going to stay on my mechanical drives here just to keep things organized. And I've excluded the 3 NVMe drives from that array. Conversely, if we go back over to my app data folder here, I have only the SSDs assigned to that. So for all of the Docker containers that I put on this thing, my Plex server, basically anything that's going to need to do a lot of random reads and writes is going to run off of the NVMe drives here for better performance. And I'm already seeing my Plex server being so much more responsive as I'm browsing it, because it doesn't have to wait for the drives to spin up, and all of the information on an SSD can get accessed a lot quicker. Let's take a look now and see how it performs. Now, one thing that I've learned the hard way with this project is that caching on Unraid is really important, even if you've got NVMe drives on board. Let me show you what I mean by that. So if we take a look at my current setup here, we've got my media array that is writing directly to the array. We don't use the cache here, at least not in how I'm currently configured. And what this means is that when data is written to a drive, it is going to also have to write out the parity information to my parity drive on the array. So when I start this disk speed test, for example, check it out. We're going to get some really good speeds here. We're pretty much running at the full network speed of about 240 megabytes per second. But right when we hit the midpoint here, the performance is going to drop off substantially. And that's because the system is having a hard time keeping up with the parity writes that are necessary to protect the data. So if we had a drive loss and we swapped in a new drive, the parity drive can replace the data and we don't lose anything. But it slows down writes for large files considerably. Now, if I had a beefier system here, I would imagine this would take a little less time. But what I found here is that when I'm copying over, for example, 3 gigabytes, like the speed test is doing, it will slow down, and then the final write confirmation takes quite a bit of time to come through. So typically with this speed test, if I'm running it on a local drive, it writes out, and then it switches over to the reads, and we can continue on. Here, as you can see, we're still waiting for the drive to catch up with all of the parity information getting written to the parity drive. And so let me let this cycle. I'll show you what the read speeds are just off the mechanical drive, and then we'll take a look at how the cache performance will improve things dramatically. So now that the test cycled, you can see we were getting about 270 megabytes per second on reads off of this. So for my purposes, where I'm usually just reading from these disks, I've got plenty of performance here. But let me show you what happens now when we enable the cache and how much better things run, at least on this setup. So I'm going to go over to my shares here. I'm going to go to my media array, which we were just writing to. And you can see here that we had it configured just to write everything directly to the array without using the cache. And I was doing this because I brought over a tremendous amount of data, about 3 or 4 terabytes of media files, and I didn't want to fill up the cache doing it. So now we're going to write to the cache for primary storage. I'm going to set the array as secondary. And what this means is that we're going to write to that cache drive, an NVMe drive first, and then there's a scheduled operation that runs that moves the data from the cache to the array, so I can get the benefit of the massive storage that I have installed on here. So now that we have made that configuration change, again, cache to array, and now what you'll see is about 200 and something megabytes per second consistently on writes. We're not going to see that slow down at the midpoint here because we're not involving the parity drive until we do that move later with the scheduled task. You can also see that that write finishes up pretty much when it's done, but here you can really see the benefit of using caching with your array, especially if you're moving a lot of files into your array frequently. Reads aren't as affected as much. So let's take a look now at what applications I have running on the NAS right now in Unraid. And of course, Unraid is very good at Docker containers, which we covered in my prior video. So I've got my HD home run DVR running here. I'm recording to the mechanical drives with this one. I was able to copy all of my previously recorded media over to this new system, and it's been working just as well. Everything pops up at the same rate of speed. And of course, when you have the HD Home Run DVR enabled with their TV tuners, it routes everything through the NAS first before it goes to the client. But again, no difference in performance here, even maybe a little bit quicker in getting things spun up, so all was good there. I'm going to show you Immich in a minute, which is a photo organization application, kind of a Google Photos open source alternative. And they have 2 other containers that Immich works with. That includes the database here and a redisk caching server. I also have Plex running on this, and as I mentioned at the outset, currently this hardware on Unraid doesn't support hardware transcoding. If you were running the latest version of Ubuntu or running a Windows Plex server, this N150 would do just fine. In fact, we just did a video about HEVC transcoding with this processor. The issue right now is that Unraid is not supporting the GPU on this N150 hardware until version 7.1 comes out in a month or 2. So when that happens, I'll revisit this. We'll look at the transcoding. But for my purposes, I generally don't do a lot of transcoding on Plex because I mostly just watch media in the home where I can do direct streaming, and that has been fine. Everything pops up just about as quick as it did on the PR2100 NAS. So no issues with Plex beyond the hardware transcoding issue, which is probably a big deal for many of you who do rely on transcoding. So this is not yet ready to run as an Unraid Plex server. But why don't we take a look, though, at Immich here, just so you can see how fast it can process things. Now, as a reminder, I have my applications running off of the NVMe storage on the NAS and not off of the mechanical drive here. And for Immich, that also includes storage of the photos. So what we're going to do here is just jump over to Immich, which is already loaded up. And I have an album that I created called 2002 Photos, and I found a bunch of photos from around that period of time in my archives. One of my projects that's been on hold for a while is getting some of my older photographs organized because the software I was using for organization wasn't updated here. And I did have one little error here. It looks like a duplicate that it picked up, but everything else, as you saw, went in super fast there. And if I just refresh the page, you can see just how quickly Immich responds here as I'm scrolling through the images. So really fast, and that's one of the advantages of having solid state drives for storage, but also driving your applications. It is super snappy here, as you can see. And of course, they have a lot of optimization built into this application with the redisk server as well. But altogether here, it's a super fast and responsive experience to get my photos loaded in here, and that's thanks to the solid state storage on the NAS box here. So all in, this has been kind of a fun project to see if I could build or piece together something that could work as well as my existing media server. From a practicality standpoint here, this isn't great. Got wires all over the place. I think I would prefer to have something that was all fully self-contained, but I've got to find something that can support 4 NVMEs and 4 spinning drives in a single case. And from a performance perspective, this has actually been running better than I expected. I did switch off my WD server to see how this thing would work for a week, and it's been working just fine, pretty reliable, no issues that I've been able to see beyond the transcoding thing I mentioned earlier, and it's been really fun to just have something different running everything. What I like about Unraid is that if I decide this setup isn't practical anymore, I can take all the storage out, put it in some other device, take that external drive and plug it into the USB, and now I've got my server booted up on something else. It's very, very portable. And of course, the Docker containers that you run on Unraid are also very portable. So I've got a good solution here to maybe migrate to something else down the road. Now, I think the value point here with the GMK device is using it as its own self-contained unit. So you've got a bunch of NVMe storage in here, and you're kind of running it as an application server. It's a great use case. It doesn't take up much room. It's very quiet. It does consume a little more power than I expected, but it is very fast because of those SSDs, even with a lower-end Intel processor driving everything. So for a very compact NAS, I think it's quite effective, and it gets even more effective when you attach additional storage, cheaper, slower mechanical storage for things that don't need that NVMe performance all the time. So that's it. It seems to work. I would love to get your thoughts on this down in the comments section. I'm sure I'll get a lot of it, and we'll keep looking at this project as time rolls on. I'm going to keep this running for a little while, and then when the Unraid upgrade comes out and we can really test the transcoder, we'll come back and look at this. And then at some point, I'll probably move everything into some other piece of hardware, and we'll just keep running with this story as long as it takes for me to get something I'm satisfied with. But all in, pretty cool stuff, and I will be back again soon with this crazy setup as we explore it further. Until next time, this is Lon.TV. Thanks for watching.